area of straight-sided shapes. So this is a really quick overview of finding the area of 6 straight-sided shapes and composite figures and solving some problems with them. Just a reminder that, of course, when we're finding area, we are finding out the number of square units, such as 1 centimetre squared, that are taken up by a two-dimensional shape. Because we want area in 2 dimensions, our dimensions are always going to be at right angles, because the dimensions of a square are at right angles, and so if we're counting squares, it's what's the length in that dimension, and what's the length in that dimension. So anytime you're not certain with a straight-sided shape which lengths to use, you choose the dimensions that are at right angles to each other. Now for a square and a rectangle and some triangles, that's pretty easy. And a reminder though, of course I know you know it, when you're finding the area of a rectangle, you measure its sides, that's 3 centimetres by 4 centimetres, and the reason that my area is length times width is that, well, that's 3 lots of 4 centimetres squared. So instead of having to divide it up like that and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I know I've got 3 rows of 4 or 4 rows of 3. A triangle, and in fact all these other straight-sided shapes, are actually based on that rectangle formula. So this triangle, here I've got its base and its height, which are at right angles to each other. If I made a rectangle with that base and that height, the triangle would take up exactly half of it, which is why the area for a triangle is half of the base times the height, because it's find the rectangle and get half of it. And all these other shapes come down to, well, how could we make it into a rectangle? So the area formula for a square, this is S for side, area is side squared, side times side. They're at right angles, it's like a rectangle. Rectangle, area is length times width. You don't have to write the times, so you can write area is length times width, like that. The triangle, now remember we can get all sorts of different shape looking triangles. The right angle triangles are easy, base and height. Base when the height is inside, but they're at right angles to each other, so that's clear. Sometimes the base and the height are quite sort of confusing, and the height is shown outside the triangle, but they show us that it's at right angles, and so we know that that's the base and that's the height. So if they go throwing in extra numbers, especially with triangles, don't be confused. Choose the dimensions at right angles, and my formula is area is half base times height, or you can write area is base times height divided by 2. Let's just put boxes around these formulas so we know what we're doing here. Either of those is fine, either of these is fine. Now a parallelogram, if you think very sensibly about it, you'll see that if I take a parallelogram, cut off that bit, and move it over to there, what I've got is a rectangle. The base length hasn't changed, the height hasn't changed, so the formula for the area of a parallelogram is base times height. Or of course we can write area is base height with no times sign because it means the same thing. That's your parallelogram. Rhombus and a kite. So remember a kite, 2 short sides, 2 long sides. Rhombus, even sides, like a squashed square. Now these ones I won't go through how you get the formula, although I'm sure if you're feeling clever you can work it out. The dimensions are across the middle. They're called X and Y, and they're given in a cross. Sometimes they're given outside, sometimes they're given inside, like that. But they're the crossways dimensions in the middle of the shape, and that means they're at right angles. And your area is X times Y divided by 2. So the 2 right angled dimensions that are crossing in the middle of the shape there, X times Y over 2. And the trapezium's the last straight-sided shape that we need. I've drawn two here because this one sometimes messes with you. Now you could do them as triangles and rectangles, but I'm running out of grid paper here. When you take a trapezium, it's got two parallel sides, they're called A and B, and if you average out A and B, cut that bit off there, so not all the way where the triangle is, half of it, and move it up to there, cut that bit off there and move it up to there, you'll see that the height has stayed the same, but the length of this rectangle is a bit shorter than the long side and a bit longer than the short side. We've averaged the two parallel sides to get the base of this rectangle that still has the same area. And so my formula for the trapezium averages the two parallel sides, A and B, A plus B divided by 2, and then multiply that by the height. So it's just making it into a rectangle and finding the area that way. So all of these formulas come back to the rectangle and square. Now when you're finding the area of a shape, you do need to write the formula first. This is a trapezium. Area is A plus B on 2 times height. Substitute your values in. So the height is the distance between those two parallel sides. So see, they're still at right angles. Area is, now 3 plus 11, that's 14. Divided by 2 is 7. 7 times 5, 35. And you put your units. We're in millimetres, so we're measuring millimetres squared. This shape here is a composite shape. That is, it's made up of two shapes, or two or more shapes, added or subtracted from each other. So here I want the area of this 1 metre wide path. That means I'm going to have to find the area of the big rectangle, the area of the little rectangle, and subtract, because this path, this area was obviously taken out. Now that means that this length here, that's 1 and that's 1 and this is 10, that will be 8. 5 here, we're taking away 1, 2, so that will be 3. So it's a good idea to label what you're finding. Area of large rectangle. Area is length times width. 5 times 10. Area is 50 metres squared. Area of the small rectangle. Area is length times width. 8 times 3, so that's 24 metres squared. And then area of path, I'd leave more space if I had it, is 50 minus 24, which is 26 metres squared. So you're subtracting, some shapes you're going to add. And a problem-solving question, find the side length of a square with area of 3.6 metres. So they've told me the area and they want the side length. There's a formula for the area of a square, so you write it. Area is side squared. You substitute in the values we know. I know the area, I don't know the side. 3.6 is equal to side squared. And then you've got to work out from this, it's an equation. I've got the side squared, I want the side. Now normally when we've got an equation, I have to do the opposite of what I did. So I squared the side. The opposite of squaring is the square root. So the side is going to be the square root of 3.6. You'll need your well, you won't need your calculator, but I suggest you grab it. Square root of 3.6 is, oh, you didn't need your calculator. Here I was thinking I was being so clever and we could work it out in our heads, but I was wrong. 1.9, and we are in meters squared. So that is a bunch of area and problem solving that should get you through a couple of exercises.